Okay, here's another little problem to help you learn how to use the kinematical equations. A race car accelerates from rest at 5 meters per second squared. The car passes through 2 photo gates located some distance from the starting point. The distance between the photo gates is 6 meters, and it takes 0.187 seconds for the accelerating car to pass between the gates. How far from the starting point is the first gate? So let's start by creating a coordinate system. We'll measure x in this direction like this, where this is x1, this is the first gate, and x2 over here is the second gate. And the little car starts down here at the origin and accelerates this way at a equals 5 meters per second squared. All right, so if I have an object accelerating in the x direction, then the general equation that describes its motion is x of t is equal to 1/2 a times t squared plus v initial times t plus x initial. Well, x initial is 0, so that term can go to 0. If it starts from rest, the initial velocity is 0, so that term goes to 0, and we get simply that x of t is just equal to 1/2 a t squared. Very simple. So if we want to find out how far it is from the origin to x1, then we can write the equation x1 is equal to 1/2 a times t1 squared. But we also know that it arrives at x2. In this equation, x2 is equal to 1/2 a times t2 squared. But we have a connection between x2 and x1, namely that this distance right here, delta x, between x1 and x2 is equal to 6 meters. Delta x is equal to 6 meters. And the amount of time it takes from t1 to t2, call it delta t2, is equal to 0.187 seconds. So we have a connection between t1 and t2, namely that t2 is equal to t1 plus delta t. And we know that x2 minus x1 is equal to delta x. And if I rewrite that, I can write that as 1/2 a times t2 squared minus t1 squared. I'm going to move this up just a little bit. So delta x is equal to 1/2 a times t2 squared, but let's look at t2 squared. t2 squared is equal to t1 plus delta t squared minus t1 squared. So now we have an equation just involving t1, which we should be able to solve for t1. And once we have t1, we can put that back in here to find out what x1 is, and that's what the original question is. So I'll do a little bit of algebra here. This is equal to 1/2 a times, well, expanding this is t1 squared plus 2 times t1 delta t plus delta t squared minus t1 squared, like that. And this t1 squared takes out this one, and I'm left with 1/2 a times 2 t1 delta t plus delta t squared. And all of this is equal to delta x. So let's rearrange things just a little bit here. In other words, this implies that 2 times delta x over a, that's from this term and this term, 2 delta x over a is equal to 2 t1 delta t plus delta t squared, or 2 delta x over a minus delta t squared from this term and these, this term here and this term. This is equal to 2 times t1 delta t, and if I divide both sides by 2 delta t, then I have that t1 is equal to 2 delta x over a minus delta t squared all over 2 delta t. This is t1, so I just have to plug in the numbers for that to find out what t1 is. And I'm going to pause for a moment. So plugging in these numbers, t1 is equal to 2 times delta x, which is 6, divided by a, which is 5, minus delta t squared, which is 0.187 squared, and all of this is over 2 times 0.187, and that works out to be, let me grab my calculator. So let's plug that in, and let's see, we have 2 times 6 divided by 5 minus 0.187 x squared equals, this is all in the numerator, 2.365 and so on, and we'll divide all of that by 2 divided by 0.187, and that's equal to 6.32, for approximately 6.32. So the answer is 6.32 seconds. Okay, so now we need to use that number in order to calculate x1, and that's just simply a matter of plugging in this equation. X1 is equal to 1/2 a t1 squared, so that's equal to 1/2 a, which is 5, and t1, which is 6.32 plus some digits squared, and that is, well, I kept all the digits here, so if I square that, times 5 divided by 2 equals, I get 99.97 meters, approximately 100 meters, approximately equal to 100 meters, and that's the answer.